Okay, let's continue watch the remaining part of the phone interview example.
Otherwise, it'll continue. Okay, good. So then let's see. And for each neighbor, we want to actually check its neighbors too, right? Let's see here. If it's an island, we want to keep checking its neighbors. Yeah.
Mm-hmm. Yes.
Okay. Let's see. Okay.
Yes, now you got the recursive call.
Yeah, so now we've got the recursion. And as we're going through, if it's an island, we're adding, where are we adding to the scene points? Probably not.
That's a good point. Yeah. I'm gonna mark I have visited here.
Yeah. Now this could be private, but we'll leave it this way for now. Okay, so point island, point island, point island, point island append. Oh, I see. So we're appending. This doesn't seem right anymore, actually, because we're adding the point to. Okay, so we start with a point, and we look for its neighbors. And if the neighbor, this is going to be problematic anywhere. Okay, if the neighbor point is an island, then we want to, it's like you need to keep track of the island's first point so that you're adding the neighbors to that island rather than to another island, to another point's islands, right? So we don't want to add, I don't think we want to add the neighbors' points in, let's see here. Does it matter actually? Does it matter if we add to, we want to make sure that we're adding to the parent, but we want to make sure that we're adding all of the children too.
Yeah, we want to add all the children's too. Like whenever we visit a new place, like when checking neighbors and when we want to mark visited points, we need to add them to the visited place.
I see. So it's really like your point, neighbor point. Let's try that.
Yep.
So
because if it is not an island, we'll just skip.
if it's not an island, we'll just skip.
Uh-huh.
Right. Yeah, but the problem that I'm trying to figure out is like how to make sure you're adding all of the children neighbors to the primary island point rather than making a whole bunch of sub islands that are all part of the same island, really. You know what I mean?
Yeah.
Yeah. So, okay. So,
Let's see.
point to check. So this is, we'll call this the island point, and this is the point to check. Okay. So neighbor point of that. If the neighbor point is in the top visitor points, then we continue. Otherwise,
But I
we
think you
add
don't
the
need to
neighbor
remember
point.
everything. If you can just mark every visited point for island, that should be fine, right?
If
And
we mark every visited point as an island or not? Is that what you
yes,
said?
no, every visited point, if you can remember every visited point for island, and that is sufficient, I guess, right? So, and then you're gonna have a counter, island counter. So currently, the initially island counter should be 0. Whenever you find an island, and then you're gonna increment that counter, and then you're gonna mark all the connected points as visited.
Yeah, so we'll mark all the connected points as visited. I guess what I'm stuck on is as we're going through, like getting at any point, we should know we should know how many islands we have at that given point, but that number can change based on whether that point is part of another island. But you're trying to keep track of the connected points. Yeah, so
Yeah, now I see that what you need more is just a counter, right?
for when we create islands.
Yeah, when you find an island, you want to increment that counter.
Mm-hmm.
That I guess that's it.
Oh, wait. Yeah, you're right. Why am I thinking about this? Because I was still thinking like I was going row by row through the matrix, but I'm not doing that anymore. I'm going point by point and connecting all the points. So
Yeah.
really, when we so this guy, so as I'm going through the points, and it's not visited. Okay, so we gotta do this. I hear what you're saying. Thank you for correcting me.
You will. I think you're almost there. Yeah.
Yeah. Thanks. So endpoint. Then we just continue. If the point is island, we want to make an island. Or maybe we just need a counter of island. You're right. Do we need an island?
No.
What would I use this for?
Just a counter.
The point has an island and we're appending it to it. Yeah.
Just a counter and an increment.
Self island counter. I don't think we're using this one. Island counter 0.
Yes.
Weird thing to have that. Anyway. Okay, I don't like that actually. Number of islands equal starts at 0 and then we're counting. Count islands is island. Number islands plus 1. And then we check the neighbors of that point. So we just need to keep adding them, and that'll add them to the visited. And if it's not an island, then continue. That's good. So if the point is an island, then we keep going. So I don't need any of this stuff anymore, right? Okay. Our neighbor point is up here. If the neighbor point isn't visited, continue. Otherwise, we add the neighbor point to the visited. If it's an island, then we don't need to do this anymore. Yeah, we do. Do we? No.
You need to
keep track of this anymore, right? It's irrelevant. It doesn't need to know its island points.
I think you need it. You need it.
We do?
Isn't it?
Well, so let's think about this.
At every point, you get the neighbors, and then if the neighbor is visited, just skip it. And if that's an island, island, you want to add that to the point island dictionary, and you're gonna go further.
Well, so if the point is an island, we want to go further, but I don't know that it matters. I don't know that it matters that we're tracking points. Oops. I don't know that it matters that we're keeping track of the rest of the island with the point.
You're right. You don't need to track. You could just already checked everything, and then you already marked as visited point. So you don't need to track if that's an island or not.
Yeah.
Yep.
Visited points append. Yeah.
Yes.
So we don't even need to know if the point itself is an island or not.
Yes.
Right?
Yes.
Even though it seems like it'd be good to know that. Here anyway, even though we don't need it for now. If we were going to store it to a database or something, is island. We can't do that actually. Island. That's true. We don't need that now, but I'm just going to do it for my own sanity.
All right.
Okay, so we're checking the neighbors. We're going to get the point. We'll keep going through the point, and it'll keep going as long as it has neighbor points, which are islands. It'll keep expanding out from that circle until it reaches the end. And each time it does, it will track whether it's visited or not. Are we going to have some sort of a race condition here?
I don't think so. I think you are almost correct.
I'm almost correct.
Yeah, yeah.
Right,
I think I think your algorithm is correct, but I have a question in some other place. But
Okay, go ahead.
yeah. Okay. First question. Algorithm complexity. Can you tell me about the time and memory complexity?
Yeah, let's see. So, time complexity. So the matrix has really n by m entries,
Yep.
and in order to count the islands, we're going through each point at least once. So that's n times m.
Mm-hmm.
And then for each point, we're going potentially to the rest of the world. Is that right?
Yes.
So it's n by m squared. That doesn't seem very good.
Well,
But we are keeping track of the ones that we've seen already, so we shouldn't visit any point more than once.
you are not.
Even though we're iterating through them, but we're not doing much work for each one other than checking whether they're in this
You are not. You are not.
area. Visited points. Now, as far as the memory is concerned, you've got you're storing the points twice, n times n times m twice, right?
Yeah.
In order to count.
For
That's
very
problematic.
Let's see.
Maybe it'd be nice if we could just edit the point itself, right? Like we have this point thing. Maybe we put point is visited as well. Would that help? So then, as we're going through, if the point is visited, then who's going to keep track of that, really, right?
Yeah. So basically, I think at least you need twice more memory because you have a matrix, and then you need to have like a similar type of structure tracking the visited place, like is visited matrix or is visited memory for each point.
Yeah.
And what else? If you should keep storing
the islands, but that's just a constant, so that's pretty.
It's fine. Yeah.
No, it does seem like that we can get rid of the visited points though by tracking whether it's visited or not on the point. I'm just struggling with like where we're actually going to store that, if it's going to go away or not.
I think it's possible to go it away easily, but yeah, I think you don't need to do that. At least we need to track the visited points. One hack is that if you are allowed to modify the input matrix,
yeah,
you can mark it there.
Yeah. Matrix edit. Oh, sorry, feedback. All right, so if we can modify the matrix again.
I think we are out of time.
Okay.
Yeah, I think that. Thank you so much. I can see that how it works, and I can see that your algorithm is well implemented. The only question that I have now is this.
Sorry, where are you?
Yeah, like in the get neighbors function, you generate an array of 4 points, like x plus minus 1, y plus minus 1. What I'm wondering is that out of bound access.
Oh, good point. Yeah. So we need to know. So I'm wondering if the point itself should know about its neighbors, and as you're constructing it, you can construct the neighbors. It's storing an extra lot of data though.
That may be possible, but if you can easily check if x is within 1 to number of columns minus 1, y should be 0 to number of rows, actually minus 2. Row minus 2, x is 1 through columns minus 2.
Yeah.
Yeah.
Yeah, you're right. So if we added the number of rows and columns here,
Yes, yes.
and then we could check those. As we're going through here, we could check that, right?
Yes. Yeah, I think it's fine. You don't need to implement now. Yeah.
I like it. That's better.
Awesome. Great, great, great. Yep.
Cool. Well, thank you for walking me through a fun exercise. That was good.
All right. Thank you so much. Yeah. Yeah, I can see how you implement it and then how strong you are for Python. I see the really Pythonic code.
Cool.
Cool. Yeah. Thank you. That's it. So I'm gonna give you my feedback later on.
All right. Sounds good. Well, thank you for the time.
All right. Great. Thank you. Bye bye.
Bye.
Okay, how was it? I'll give you my feedback. Coding, I think he has a quite strong Python skills, but unfortunately, I think that his coding is a little bit slower than other candidates. Unfortunately, his coding was a little bit complex, and there are several mistakes, like out-of-bound memory access. Analytical skills, unfortunately, it is weak because he couldn't find that this question can be solved using depth-first search. And actually, even though I gave the term depth-first search, he couldn't implement it correctly. And also, his implementation requires some unnecessary memory. Communication skills is quite strong. He was able to deliver what he thinks, and then when he was stuck, he requested for hints, and I gave hints, and he accepted all of them. He has a quite strong conversational skills too. Okay, overall, I would give 2.6. 1.0 is a very low score, 2.0 is a still low score, and 2.5 is a borderline, and 3.0 is a strong candidate, and 4.0 is a really strong candidate. 2.6 is fine. If he could show good performance in other interviews, 2.6 is totally fine. But in this interview, he couldn't demonstrate strong analytical skills. Again, he has a good Python skills, but the coding was a little bit slow and he made several mistakes. And unfortunately, I would say his analytical skill seems weak. Again, in this session, we watched an example of phone interview. The candidate got his bachelor's degree in chemical engineering and math, and he already spent 20 years in industry. Overall, in this interview, he did quite good job, but not really strong. I guess he has been working as project leader for several years. Like in the case, it is expected that his technical skills may be rusty. I believe if he practiced a little bit more, he could definitely excel. Okay, that's it for the phone interview example.